Okay, we're still talking about solving equations. This says, why should the equation x minus 1 times x plus 3 equal 17 plus x, and x minus 1, x plus 3 equal x plus 17 have the same solution? Well, all we did is swap the order here. So that would be what we refer to as the commutative property. That's the reason why those would be the same. If I can make it a little bit bigger, maybe on this next one here. All right, so that's the reason why that one is it. Now let's look at the second one. Why should the equation, all right, so it's the same equation. Oh, same thing. All that we have done is swap the part on the left side of the equation. That's the only thing that's happening. It's just swap. So once again, that is the commutative property. Commutative property. All right. Do you think the equation, you see it there, should have the same solution set? Why? Okay. So why would this have the same, or does it? So we've added 500 to this side, and we've added 500 to this side. So yes, that would be the exact same thing, because all we've done is added 500 to both sides. So should it? Yes. Because 500 has been added to both sides of the equal sign. Remember, that's just manipulation. We're not doing anything to it. We're just manipulating it. It all is the same thing. That still applies. All right, let's look at this next one. Is it the same? So, yes, I probably won't type this one out. I'll just show you. This is a little bit trickier though. So what's happened here? Well, they've added 3. I'm sorry. They've multiplied the 3 here, but they've also multiplied 3 times 17 plus x, and they got 51 plus 3x. So yeah, it's the same thing. They just multiplied 3 to both sides. Over here, for this one, they didn't distribute. Here, they distributed. I'm sorry. Let me go back. That's not correct either. On this side of the equation, they left it undistributed. They just put the 3 out front here. Okay. But for this side of the equation, they actually distributed the 3, because they had 3 times 17 plus x, and they distributed it and got 51 plus 3x. All right, page 2. It says, use the commutative property to write an equation that has the same solution set as x squared minus 3. Okay, so let's just do it on both sides of the equation. So we'll do commutative property. We'll say negative 3x plus x squared plus 4 is equal to, let's say, 5 times x plus 7, x minus 12. We've not changed anything, just rewritten it. Just different. We just swap it around. Commutative. Remember, back and forth. It doesn't matter which way, because it is the commutative property of addition and commutative property of multiplication. Now it says in B, use the associative property to rewrite. Okay. Now, associative property is a little bit different, because we got to regroup. We leave it the same way, but we're going to group things differently. Okay. Remember, grouping, associative, a group. So let's just write the thing out. Now we're just going to group them. There we go. That one's grouped, and let's group these. And so this says we're going to do x squared minus 3x first. And on the right side, we're going to do x minus 7 times 5 first. It doesn't matter because it's associative property. Does this reasoning apply to the distributive property as well? Yes, it does apply to distributive property as well. Yes, as long as you do it to both sides, it doesn't matter. Okay. So let's go on to exercise 2. Oh no, what is this? Let's go get that. What is that? Why in the world? What is this? Why is there a Google or Zoom on here? Go away. Okay, let's see what happened there. Let me delete this then. Let's go to delete, and I will just write it out for you, okay? What it said, consider this equation, x squared plus 1 is equal to 7 minus x. Okay, and it says verify that this has a solution set of -3 and 2. Draw the solution set on the graph, okay? So it says that it gives us where the solution set is -3 and +2, okay? Which makes it look like this on the graph, -3, -2, -1, 0, 1, 2. So we're going to have just a dot on the 3 and a dot on the 2. It's really hard for me to make. I wonder if I can do it better with a highlighter. Oh yeah, that's better. There we go. I like that better. Okay. So there they are on the number line. Now let's see, is that true? Well, -3, oops, I don't want that now. I'm gonna go back to my pencil. Okay, negative, I want to go back to the pencil. Let me use the pencil. Click on it. There it goes. Nope. Let me figure this out. Sorry, guys. But I don't want to use a highlighter. Let me just use the pencil. There we go. -3 squared plus 1 equals 7 minus a -3. Well, this is Mr. Kawasaki, so that's 7 plus 3 equals 9 plus 1. Is that true? Yeah, that's 10 plus 10, so that is true. Let's try 2. So if we said 2 squared plus 1 is equal to 7 minus 2, that's 4 plus 1, and that is 7 minus, so that is 5. So yeah, that is 2 true statements there. That works. B then said, let's add 4 to both sides of the equation and consider the new equation. Well, if we add 4 to both sides, is that going to change anything in this equation? Up here, if we put +4, and over here we put +4? No, that's not. Once we work it all out, if you do the same thing to both sides, it doesn't matter. It's the exact same thing. So B, whenever it says consider putting them on both sides, verify that they're both still true, that 2 and negative 3 are both true? Yeah, they're still true. It says now let's add x to both sides of the equation and consider a new equation. So if you add another x, is it still going to be true? Well, let's see. If I said x squared plus x plus 1 is equal to 7, okay, minus x plus x. Well, those are going to cancel. And if I said, let's use 2. 2 squared plus 2 plus 1, does that equal 7? Well, 4 plus 3 equals 7. Yeah, it doesn't matter because you're doing the same thing to both sides. The next one says, let's add a negative 5 to both sides. It doesn't matter. If you do it to both sides, it's always going to be true. Then it says, let's multiply both sides by 1/6. Once again, if you're doing it to both sides, it's all going to be the same. Maybe that's on the next page. Yeah. See here, these are both saying to both sides. Both sides, they're still true. It doesn't matter as long as you do it to both sides. What about F? F says, let's go back to part D and add 3x cubed to both sides. Once again, it does not matter because you have done it to both sides. Both 2 and 3 will still be the same. Those are true. That will make both sides still true. Both sides of the equation, if it's done to both sides of the equation, it does not change the outcome. So if 2 and negative 3 had been false, they did not make the statement true. No matter what you do, if you do the same thing to both sides, it would still be false. Here it was true, therefore it all remained true. That should be very, very common. You should know that by now.